Three, two, one. Okay. Good evening, everybody. My name is Prashant, and today I'm joined by my teammates, Shashrika and Robin Casey, who will be joining me in presenting this presentation. Um, this project integrates web development, cloud infrastructure, and machine learning services to create an automated attendance platform. Now, moving on to the next slide, the project overview. We built a cloud-based face recognition attendance system that replaces manual sign-ins with automated face detection. The system includes a web UI, a Flask backend, a PostgreSQL for data storage, and AWS recognition for matching faces. Everything is deployed on an EC2 instance using Nginx and GUnicorn, so it runs like a real production application. Overall, it integrates web development, cloud services, and machine learning into one working solution. Now, talking about the motivation of this project. The motivation of the system comes from the inefficiencies of manual attendance tracking. It's slow, error-prone, and difficult to audit. Our goal was to design a system that is fast, accurate, verifiable using facial recognition. And that was our motivation for creating this project. And moving on towards our SDLC, software development lifecycle, we followed a structured SDLC approach, beginning with requirement analysis, exploring alternative solutions, designing the architecture, developing the system, testing each module, and finally deploying it to the cloud. Now talking about the requirements, the functional requirements of this project. Functionally, the system enrolls students, capture images, verifies faces, and then stores logs, non-functional requirements, focus on security, scalability, speed, and cloud reliability. Now talking about the non-functional requirements. The non-functional requirements of this project is that it's high in availability, secure data handling. We force webcam for live photo capture. We have got scalable AWS storage. We've got user-friendly web interfaces, and it is cloud hosted via Nginx. Now talking about the objectives of this project. Our objective was to build an end-to-end attendance workflow where the user interacts with the web UI, where the Flask API processes data, the recognition identifies the face, PostgreSQL stores the record, and the result is displayed immediately. Now talking about the impacts of this. This is the figure, the flow figure that shows the impact of our project. Now talking about the system diagram. Here we got the flow diagram that shows how our system flows, where it goes from the user to web UI to Flask API to our database, and our database analyzes the answer. These are the components of our systems, and we are talking about the major components of our system. We got the Flask application, which is routing logic and templates. We got PostgreSQL as the database. We got the AWS recognition, which is used for facial recognition. We got AWS S3 for storing the face images. We got the GUnicorn, which help us with production. We got the Nginx, and then the EC2 Ubuntu server, which is hosting all of this. Now, this is the Flask rerouting screenshot that we got that shows where our project is running on. Now, we're talking about the technologies and tools used. For this project, we've used Python, we've used Flask Framework, we got GUnicorn, Nginx, PostgreSQL 16, we got the AWS S3, which is used for the server. We got the AWS recognition for facial recognition. Ubuntu is the system that we're deploying it on. We got SSL in order to secure our webcam data. Those are the technology and tools used. Now here are our database details. We've got the student table in this database, which shows all of our data type that are being stored in our database. And this is the attendance logs of our database. Now we're talking about the cloud instances. The AWS EC2 instance goes into the Ubuntu systems. It goes into the security groups, and then the application stack. We deployed the system on Ubuntu 24.04 EC2 instance with Nginx and gUnicorn. This server uses HTTPS and acts as a secure reverse proxy for our Flask API. Now, we're talking about the data visualization. This slide explains the full enrollment of our attendance workflow, from capturing the images to base 64 encoding to uploading it to S3 to face indexing to matching and then returning the results. Now talking about cloud security. Our security model includes IAM policies, HTTPS encryption, private database access, and strict AWS permissions. Our only backend can call recognition and S3 with restricted access keys. Now we're talking about the development screenshots. Here are some of the screenshots that we have added in our development process. This is the home page of our project. This is the page where we enroll new students, where they can take their pictures, they can add their student ID and their name. This is where you could check your attendance. You could scan your face, and it will show whether the marked attendance is successful or is unsuccessful. Now, this is the students page where we have listed all the students that have enrolled. Now, talking about integration and testing. We perform integration testing to ensure API, database, and AWS services were working well together. We tested multiple images, lighting condition, and error handling cases to ensure reliability. Now, talking about the implementation of this project. The full implementation involved configuring AWS, deploying the Flask API with gUnicorn, setting up Nginx as a reverse proxy, configuring the SSL, and integrating the database and cloud services. Now, talking about the evaluation of this project, we achieved accurate face recognition, fast response time, stable cloud deployment, and secure data flow. Our challenges included debugging HTTPS redirection, handling image quality issues, and tuning recognition thresholds. This is again an example for match found of the faces and no match found of the faces. Here are some of the future works of this project. In the future works, we plan to add mobile support, multi-class attendance separations, real-time analytics, dashboards, and perhaps two-factor authentications. Thank you. This is our project. Okay, this is a quick walkthrough of our project. This is our main dashboard, where you could go to enroll new student or start a new face scan. You could view all the students that have enrolled. So now let's start by enrolling a new student. As you can see a live camera over here. All you need to do is enter the student ID. This is going to be my student ID. I'm going to enter my name and then capture a photo. As you can see, I have been enrolled. Now that I have enrolled in this class, let me mark my attendance. As you can see, my attendance is marked successfully. Now, to show you an example of the attendance being marked unsuccessfully, I'm gonna go to mark students. I'm gonna grab one of my friend over here, my teammate, Robin Casey. He is not enrolled in this class. And to show the example of somebody not being enrolled, it's console like this. No match found, as he's not enrolled. Thank you. That was a quick demo of our project. Thank you.